I won't be speaking about Vaadin, I won't be speaking about Google Web Toolkit, at least not too much. So what I wanted to speak about is hybrid applications. This is a bit of a new type of approach for building web applications, and from there we go to Vaadin and Google Web Toolkit as well. But the main topic would be this hybrid approach for building web applications. So my background, I'm from Vaadin, and you know this Vaadin, it's actually a Finnish word meaning female reindeer. So that's the background of the word, and the team is from Finland. That's the reason for choosing a Finnish word. So hybrid applications, who knows which car is it? Yeah. So it's i8. So that's really nice hybrid car that has basically both engine and as well as electric motor inside. And it's actually a pretty amazing car in a way that it can generate a lot of power and it can combine basically best of the both worlds. So the second car is this one. Anyone? Any guesses? You didn't expect to hear about cars in this presentation. So this is S-Series Mercedes. I guess this BMW is costing something like 130,000 USDs. This is costing like 100,000 USDs. So pretty expensive cars. And the third ones, somebody once said that if you are throwing your iPhone in San Francisco, you always are hitting this car. So this is also pretty expensive, like 60,000, 70,000 USDs. So if you kind of compare these three cars, you see that this Mercedes, this is like traditional luxury car. You get, I don't know how to do miles per gallon. So it's 8.6 liters per 100 kilometers. So it's costing like 15, 16 bucks per 100 kilometers. So it's pretty expensive to drive. But at the same time, you have great range. You can basically drive from coast to coast because there are gas stations everywhere. With Tesla, it goes in a way that it's really cheap to drive. I mean, basically costing like 1 USD per 100 kilometers. But at the same time, you have to find out some place to charge it. So it's not that good when you're offline or off the grid. Of course, these guys are building the grid all the time, so it might be better over the time. And in between is the hybrid solution, where you try to combine the best of these both two worlds into one car. Basically have unlimited range because you can stop by and fill the tank anywhere, but you still have the good size of the electric car. So what does it have to do with apps? So you all know how web applications work. I mean, like rich web applications. You always have a backend, you always have a web server on top of that. Then there is some kind of communication channel, and then you have JavaScript-based client-side user interface. And this is what traditionally is when people are speaking about rich web applications. They are speaking about having a JavaScript-based UI on the browser side. And communication channel, basically like REST over AJAX or something like that, and a web server sending over data from your backend. This is less known, the server-side UI approach, where you only have the web server side, and these two guys are fully automated. So instead of you programming these parts, the framework does it for you. And there are multiple frameworks that are doing just like this. So if you're taking a look at the basic JavaScript stack, you are required to write all these 4 layers. If you are looking at the Google Web Toolkit, there is a brilliant way of compiling from Java to JavaScript. So instead of writing in JavaScript directly, you're writing in Java, compiling that. And optionally, you can go over and write parts in JavaScript as well. But you still have 4 layers. And both of these are strictly client-side UI approach. So with Vaadin, it's a bit different beast. You are required to write the server-side UI layer, and of course you have the backend. But because you can write any of these layers, you can actually build client-side UIs with Vaadin. And you can build server-side UIs with Vaadin. And this is a bit strange approach, having like two programming models in one framework. So if you're comparing these, comparing basically one layer versus three layers, there are like pros and cons in both. If you are having one layer only, it's quite obvious that you're writing less code, you're writing less layers yourself. So it's basically half the code, half the maintenance, much faster to develop. But if you are writing all the layers by yourself, then you have full control over the whole experience. You know when the AJAX calls are shoot over the wire, you know how the DOM is manipulated exactly. So you have more control over in three-layer approach. So more productivity with the server-driven or server-oriented approach, and more control with the client-driven approach. I guess client-driven approach needs no introductions. You all have written some AJAX apps, right? By the way, quick poll, who has used Google Web Toolkit before? Only 4 guys. Who has used Vaadin before? Only 1 guy. Okay. I hope you are then learning something new. So the server-side approach is such that you are writing your user interface in Java programmatically, like this piece of code over here, putting a couple of components on the screen, wiring up an event handling code that shows a notification when we click this button. This gets run on the server side. But what actually happens when you go with your web browser to the URL running Vaadin application, you actually get a bunch of HTML, JavaScript, images, and so forth. And the good side is that you are not writing these yourself. They come with the framework. So, and while this is like a bit over a meg of different stuff, it gets compressed and reduced to around 100K total. And this, what you get is you could say that it's a terminal or client for this framework. So this basically can render any of those UI components supported by the framework. So whether you have like 100 views on your applications, on one view or a million views, the amount of downloaded code is still the same. You're downloading 100K or 200K, depending how many widgets you are using. So the first thing is that you get this UI on the screen. When you start interacting with the UI, what happens is the framework automatically sends an AJAX call over the wire. So it's actually REST-based AJAX call having some hundreds of bytes in it, basically encoding what are the actions that the user is doing. Clicking a button, writing a name on the text box. And this gets routed back to your code running on the server side in real JVM. And your click listening code can do whatever it wants. So it can take a synchronous call to the backend, ask something from the backend, modify the UI as it wishes, and then framework takes over and somehow sends instructions back to the client that how the UI should be changed. These instructions are encoded as JSON as well, and they are like on the logical level. So they basically are saying that, hey, please put the text over there, put a tree on the left side of the screen, and that kind of stuff. So hybrid apps, I guess the question is when you should be using client-side approach, when you should be using server-side approach, and what would be the use case for combining these. For the client side, like really strict use case is offline. If you are you simply cannot do offline application with server-side approach. Of course, if your application is running on the server side and you don't have connection, you don't know anything about the application. So then you have to go to offline. Also, low latency applications like games are pretty obvious. You don't want to go over the wire when you are playing a game. And same goes with the scalability. If you are building Twitter or Gmail, you really want to offload as much of the computation to the client side as possible because the servers are expensive. On the other hand, if you are building a banking application where you just have like 10,000 users, not millions of users, servers are not that expensive anymore because you can handle basically 10,000 users with 1 or 2 servers. On the server side, I would say that the use case is use it everywhere where you don't need to be on the client side. It's quite a bit cheaper to build application on the server side, just because you are only coding one layer instead of 3. It's also a bit more secure because all of your code runs on the server side. You are not exposing your UI layer code to the client side. It's kind of a black box instead of you showing the rest of all the users how your UI works, what kind of validators are there, and so forth. And of course, you have full Java platform. So your code, your UI code runs on real JVM on the server side. You can use all the resources on the server side. You can use any language that can be run on JVM. So I have seen Scala getting quite a bit more popular for Vaadin UIs lately. And you can do crazy stuff like, I think the most weird stuff was when somebody wrote a Vaadin UI with COBOL. And that was ugly. So hybrid tries to combine best of these two approaches. But the downside is, of course, if you are having two engines in your application at the same time, you are adding complexity. You have to understand both of these approaches at once. But on the other hand, you can get best of the both worlds for it. So let's take an example. This is a small mobile application. It is more of a demo application than a real application. But maybe I should show that live. So let's see. This is a application for meter maids who are giving tickets to you. So our guys were questioning whether this is a positive demo example, but I guess this is a typical application where you want to have offline mode. So I just click through the different views. So you can, there is a normal map view. There is like list of shifts, who is working over there, some filtering for these, interactive statistics, and so forth. All of these views are built on the server side. So actually when I'm clicking something over here, this click goes to Amazon servers running somewhere, and all of this UI is built in Java. Ticket view though, this is built for offline use. So now when we have connection, it's connected all the time to the server-side application. If we would be dropping connection, let's take a look at that. So now we don't have connection anymore. We can still continue to use this UI. Actually, it should be detecting in a while that we don't have a connection anymore. I hope. So it now detects that, hey, this is in offline, and we can still write a ticket for parking on a handicap zone and maybe take a photo. Okay, I don't have a real camera over here, but take a photo and what else? Let's write real ticket. We probably need some vehicle ID. And that's it. Save it. So now we have saved one ticket to the local store. So the use case would be that the meter maid is in a parking garage and there is no reception over there, and she still has to write this ticket. So when the connection is back on, if we get Warren line again, when the connection is back on, we can try to reconnect, and it says that, hey, we have one unsynchronized item, and it sends that back to the server side and puts the application back to the online mode. So that kind of one way of using an application where there is client-side parts and server-side parts. So how is Vaadin related to Google Web Toolkit? Or you should call it GWT nowadays, not Google Web Toolkit anymore. there were just like few guys who know about GWT. So one way to learn about GWT would be to go gwtproject.org. It's a really comprehensive site about GWT. We basically collected all the material around GWT to this one site. And also, we are arranging a GWT conference this week on Thursday and Friday over here in San Francisco. So we have something like 210 guys signed up for the conference. So anything you want to know about GWT, that would be the place to be. So, quick course to GWT. You have three parts in your application. You have your user interface written in Java, you have some widgets written in Java, and you have like base Java classes. These red boxes come with the framework. So there is implementation of basic widgets and there is implementation of basic Java classes. These are put to Java to JavaScript compiler, and this compiles one version for each browser, basically. Try to kind of work through the browser differences instead of you trying to kind of figure out how to go around memory leaks in IE 8 or something like that. The compiler tries to do that for you, and it's pretty amazing compiler. Another thing over there is that it's really optimized compiler. So if you are looking at the good sides for using GWT for your web applications, I would say that the most basic and most important thing would be static typing. If you are building a large application, you really don't. You really want to have the luxury of being able to refactor your code and use all the auto-completion and that kind of stuff from your IDE. There is a really nice kind of automated way of building communication over the wire called GWT RPC. You can call to JavaScript natively from your code, so it's really easy to integrate with other JavaScript frameworks or existing JavaScript frameworks. And then there is a really nice kind of development and debugging mode. I'm going to be showing that a bit later on. But I would say that the most interesting part in this framework is that it's really, really optimized. So Google guys have used tons of time in making the output from the compiler super fast and super scalable. So you probably can write much better JavaScript using Google Web Toolkit compiler than write JavaScript natively. It makes so many optimizations. Downsides are it's a compiler and compilation is quite slow sometimes. For a large application, it might take like 10 minutes to compile your application, and that's pretty frustrating. It's quite complex beast. It's around 1 million code lines, and it has been really optimized for Google by Google guys, and they have not been optimizing for average enterprise developer that much. So adopting the framework for average enterprise team might have some rough edges. And the widgets are not the best. But there are nice widget libraries around, like Sensa GXT is quite nice widget library for GWT. So Vaadin's relationship to GWT has been such that we have been using Google Web Toolkit as a rendering engine in Vaadin. So basically Vaadin as a product has been depending on GWT. A couple of years ago, Google announced that they moved the control over the framework to a set of companies who together steered the framework forwards. That set of companies being Google themselves, Red Hat, Vaadin, Sensa, and a couple of others that are kind of setting the direction for the framework. So what we did at the same time was that we kind of took a full copy or fork, if you will, of Google Web Toolkit, put that inside Vaadin. And of course, that being a fork, what we try to do, we try to push back all the fixes, all the changes to the framework to the mainline GWT. That effectively makes Vaadin GWT compatible. So if you have a GWT application, you could basically just take that and replace with Vaadin libraries and basically have the same thing. So no benefit over there, but that would kind of open the gate for starting to to also go to the server side and building a hybrid solution. So let's take a look of the architectural point of view for Vaadin application. You always have this server-side user interface running on a web server and some kind of backend server. Or you might be running these in the same server as well, or same JVM, if you will. You are basically composing your UI out of ready-made UI components that has plain old Java classes, like buttons and trees and so forth. For each of these classes, you have a client-side counterpart. So for a server-side button, you also have a button widget on the client side. And these two guys are keeping themselves in sync, so you don't have to worry about the communication between these two guys. On top of that, there is of course theming. Interesting thing is that you can also build UIs on the client side. Put UI logic on the client side. But if you are building logic on the client side, then you need some kind of service to fetch data from, and then this GWT RPC comes back to the picture. So that's the architectural part. Let me show like an example application out of that. So what I wanted to do was basically build super simple CRUD view for an address book, and to do that 4 times. So do once on the server side UI, once on the client side with GWT RPC, once on the client side with Vaadin connectors. That's kind of the built-in mechanism in Vaadin for communication, and then do one offline mode. But I failed. I didn't have time to do the offline mode, but the other 3 parts are over there. So the backend is basically super simple. I could actually show that from Eclipse, just to give you a better picture of it. So what we are having over there is basically simple address pojos with last name and first name and so forth. So this is just plain stupid bean. And our service is pretty simple. We can get addresses, store addresses, delete addresses. So like really simple backend for an address book. Okay. So then I implemented first 2 different versions of the UI. First with Vaadin and then with practically Google Web Toolkit. So let's try the application first and then take a look of the implementation for the server-side version and then compare that to the client-side version. So I should be having, actually we probably should be running this as well. So I basically put all these 3 different approaches in one application. So this is the server-side version. There is just a table that basically lazy loads addresses from the server side. I can choose an address. Maybe I choose one from the top. I can edit it, save it, and so forth. Then the client-side version with the GWT RPC is basically the same. It actually connects to the same backend, so I have this foo over here and can edit that as well. And then I have the Vaadin connector that should be basically like pixel identical to the previous one. So let's take a look of the server-side version first. Server-side version is basically just one class. So this is one UI component made as a composite, basically putting bunch of UI components on the screen. These are living in this composite component. We get started by building layouts. In this case, we just do them programmatically instead of XML or anything like that. We can also use XML or compose visually, but here we just set components on the screen and configure them somehow. Yep.
Can you show your imports?
Yeah, sure. So over here,
Pretty much all those components are part of Vaadin framework.
yeah, basically I'm only importing Vaadin UI components, then some data binding components from Vaadin, and navigation component. That's it.
So very similar type to Swing.
Exactly. The code would be pretty close to Swing. And the first thing was kind of set up the layout somehow. Then we are connecting this to the backend. Basically, we are asking the service to get addresses from the backend. We are adding these on just basically bean item containers, a wrapper around any collection, and we are binding this directly to the data grid on the screen. So we have this address list over here, and we are setting the data source for the address list. Just take the list from the backend, wrap that around with the bean item container, and bind this to a data source. Okay. Then we wire up the action listeners for the edit button. What happens when we click a button? And I guess the only thing to note over here is that what we can do, because we are running this on the server side, we can do a direct call to the backend, and we can expect reliable answer from the backend synchronously. So we don't have to do any kind of asynchronous callbacks over here. And then we just modify the UI as we wish. These are pretty much the same. And I guess rest of it is not that interesting. So I just wanted to kind of be following good UX practices, like hiding these components over here until I click edit button, and then hiding these. So like small finishing touches on top of it. The form itself over there, it's just a bunch of UI components that I have bound with my field group. It's a mechanism in Vaadin that allows you to take a group of UI components and bind these to a common data source, and then you have like transactionality. You can commit and discard and buffer things automatically, and that's it. So that's the server-side part, or server-side implementation. So if you take a look at the client-side implementation, the UI is pretty much the same. I didn't put that many finishing touches over here, so I'm not like hiding parts of the UI, as it was a pretty hard thing to do with these UI components, and the layouts are not stretching properly. But it's, from a functionality point of view, it's pretty much the same. So let's take a look at that version. So it would be GWT RPC example, and their address book editor. So this is pretty much the same as the server-side version. So this is also a composite component. We are using a bit different components. These are now from Google Web Toolkit. So these are not Vaadin components, but Google Web Toolkit components. So instead of having a text field over there, we are calling that text box, but pretty much the same. We are doing or initiating our UI in the similar fashion. It's building the layouts. Then first differences start to happen. Like when we are initting the address list, it takes quite a bit more code than this 3-4 line Vaadin version, because that's not like any kind of architectural difference. This is more of a question of the expressiveness of those UI widgets. So this cell table is not having as many features as Vaadin table, but in the end of the day, they are pretty much the same from the kind of high-level perspective. Then there is one major difference, is that when we are wiring out these action handlers over here, for each action we actually launch a synchronous action. So when this button gets clicked, we actually create, let's see, over here an asynchronous callback to the server. So we are doing an AJAX call, and when the AJAX call returns, we either say that, hey, we just failed to contact to the server, or we asynchronously update something on the screen. So we, instead of being able to synchronously access something from the server, we have to do asynchronous callbacks. And the rest is pretty much the same. The server-side version was 190 lines, and this is 270 lines, but I didn't put all the finishing touches over here, so I guess it should be more like 350 lines or so if I would complete it fully. So that's like the UI part, but the thing is that we also need a connection to the server side, and we somehow need to put this thing on the screen. So first of all, on the server side, we need some page where we can put this component. In this setting, I'm calling it a view, and use a Vaadin view class for it. It would be a pure GWT application. You would put basically a static HTML page for initiating the application. Then in pure GWT application, you would have an entry point Java class that basically creates this UI component so that you actually have something on the screen. So you need like 3 different pieces of over there. The Vaadin or the server-side version being on the server side, it's already on the page, so you don't have to do anything extra to show that. Then you need service. Service here would be defined as an interface, defining those what kind of services you are publishing through web API. And then you have to implement this service, of course. In this case, it goes with servlet, and there is handy RPC servlet class in Google Web Toolkit that helps you to implement an RPC service. Then complicated or kind of cumbersome thing happens. This service is synchronous, and because web is not synchronous, you have to kind of define a synchronous version of your service as well. And after that, GWT can generate you a proxy class that implements this asynchronous service. But as you see the picture, it's quite a bit of, in this kind of middle communication layer, there is quite a bit of parts that you have to build in order to build the same thing. So let's take a look from the code side how it looks like. So first of all, we had this view that just puts the component on the screen. It's pretty simple. It just puts it on the screen. Then we have this connector that basically initiates the component. It says GWT create and creates a new widget. So these are boilerplate code more or less. For the service basically defines what kind of API calls we are publishing to net, and from which URL you can find these. So we just define that, hey, there is this URL that where you can go and do AJAX calls, and then you get to call these. And the asynchronous version of that is basically exactly the same, but instead of having a return value for a call, you are moving those to be asynchronous callbacks. Okay. And then the implementation of the service. This is basically just a remote service servlet where you implement your service interface, and for each call you basically somehow translate that to a call to backend. So it's really straightforward. For getting addresses, you just get the backend, get the addresses from there, somehow wrap this around with some transfer objects and send these back or return these over here, and then the Google Web Toolkit remote service servlet takes over the control and serializes these and sends these over the wire. And that's basically it. So that's the GWT RPC version of the same thing. So if you are kind of estimating the complexity over here, in the client-side version we have 4 classes, 2 interfaces, around 500 lines of code. On server-side version, 190 lines of code, 1 class. It gives you something like 3x complexity in this example. And it's actually, I think that the same kind of multiplier applies for like real applications as well, because you have to do more layers and more boilerplate code when you're coding on the client side. And this is not just about Google Web Toolkit, it's also about any kind of client side implementation. Any kind of framework you are using on the client side, you have to do those layers. We also have in Vaadin a communication mechanism of its own. This is mostly designed for server-side framework for the guys who are implementing new widgets for the framework. But it's pretty unique, so I think I could show it to you. So basically, on the server side, you have to have some kind of component. Let's say button component. On the client side, you have the same button widget. This button widget is basically Google Web Toolkit widget on the client side. And to connect these two guys together, you put a connector class in between. This connector class is basically responsible for moving client user events from the client side to the server side, sending data back from the server to the client side, like setting the title for the button. So we have two-way RPC mechanism over there for doing traditional stuff, sending stuff from the server side to client side or client side to server side. But we also have state objects, and these are pretty interesting mechanisms. So this is any kind of plain Java object that you are updating from the server side. It's shared between client and the server side. So any changes you make to state on the server side automatically get sent to the client side, and the client gets notified. You don't have to do any extra over there. You just set the state somehow. And that way, it gives you a really powerful way of pushing data from the server to the client side. And most of the time, you are just doing callbacks for user events over the RPC from client to the server side. So those callbacks would look like this. You just define an RPC interface. It's pretty much the same as in Google GWT RPC, with one difference. There is no return value. This is like one-way communications. And because of that, you don't have to define asynchronous interfaces. So on the client side, you basically ask Vaadin to create a proxy class out of this interface, and you start to use it. You just call, Vaadin implements the interface that you have designed automatically. And on the server side, you implement the interface and do something when this call is received. So the same picture again. So now there is on the right side, it's exactly the same picture as you saw already. On the client, on the left side, it's basically the same thing implemented with the Vaadin communication mechanism. So instead of having asynchronous callbacks over here, what we are doing is that we are basically sending the address list over the state, and then we are sending RPC calls to two directions. Pretty much the same complexity in both cases. But there is one kind of extra benefit for doing it in this type of way. If you're doing it like that, what you get for free is push. So in Vaadin, we have implemented a pretty powerful push mechanism that supports WebSockets, supports HTTP streaming, supports polling, and it automatically detects what your browser can do and start using those mechanisms. So if you are using Vaadin connectors or if you are doing server-side UIs, you basically get push for free. So let me show that to you how you could basically implement WebSockets for your application. I take the UI part over here, and what I do is write at push over there, save, and reload, and now it's running over WebSockets. So it's pretty simple to start using server push. And this is basically needed, or this one-way RPC interfaces are needed because we really want to be able to, from the server side, call to the client side. We basically want to push stuff from the server side to the client side. So it cannot be just callbacks. Actually, I could even prove this one. Let's see, I'll put it in the debug mode. In Vaadin we get this kind of debug window, and if you look at the communication over here, it says that it's using WebSockets. If I would be using IE8 for this same application, it should probably be using HTTP streaming. So it kind of knows bunch of servers and tries to figure out how to kind of work around any limitations on those servers to enable WebSockets. Okay, the next thing would be offline. Unfortunately, I don't have implementation for offline in this example yet. But even so, I wanted to kind of list what kind of things you would need to be able to write offline mode. So first of all, you have to be writing things on the client side. If you're writing things on the server side, you cannot connect to the server anyways. So we could use the client side version as a basis for the offline view. We need some kind of way to detect offline. In the example application that I shown, it was using a product called Vaadin TouchKit that provides a bunch of UI components for mobile applications, and it has built-in offline detection. If you are not using that, we should build offline detection somehow, and some kind of offline bootstrapping code. How we actually are starting up our offline application, basically calculating cache manifest files and doing some kind of bootstrapping HTML code for offline application. We probably need some kind of local storage as well if we want to show some data on the screen. Some kind of way to synchronize this data storage with the server side. This is really application specific, so I would claim that frameworks, while they can make it a bit easier, they really cannot solve this problem.
Do you mean like storage available in browser itself?
Yes. So local storage as in HTML5 Spectre, it's a local storage. And so in this parking application, what happened was when I was writing a ticket, it saved the ticket to the browser local storage database. When we went online, it compared client and server databases and synchronized the changes from the client side to server side. And that was totally customized logic. And it's really needed if you want to build an offline mode. And if you are having a lot of data on the server side, you probably don't want to copy all of that data to the client side. So you have to shard this data somehow. But I would say the end outcome is that you have to build quite a pile of stuff on top of the client side version. My gut feeling is that it should be at least twice the complexity of building the client side version. So if we are having around 500 lines of code for this client side version, my guess is that it would be at least 1,000 lines for offline version of this CRUD UI.
So how Vaadin is going to help you in this?
It isn't. That's the point. So I'll get back to that in a sec. So if we are, if we would believe that the offline mode would be twice the complexity of the client side mode or client side view, and we know or have measured in this case that the client side would be 3 times the complexity of the server side view, that would kind of lead that the offline mode would be, or offline view would be at least 5 times, 6 times the complexity of the server-side view. And that is basically the key. So if we are building our application in such a way that we are using server-side views for most of the application and only using offline views when we really want to have those offline features, then we could basically combine the benefits. The parts that doesn't have to be offline can benefit out of this really productive programming model of the server side, and we still can have those parts that we really need on the offline mode for the application, and combine these in one package. So if we go back to the cars and think that these would be the application frameworks, clearly this traditional Mercedes-Benz would be that client-side framework where you have 3 different layers. You have full control over everything, so it's pretty good on that respect. And it would be offline ready right out of the box because you have client-side application. You only have to be building this offline storage and synchronization on top of that. But the downside is that you have to build these 3 layers, so it's pretty expensive to drive or build. On the other hand, the server-side UIs, they are basically only 1 layer, so they are pretty cheap to drive or build, but they are limited in a way that you can drive coast to coast being offline on the way. So in a way, you have to have a server connection, you have to have this the power grid for such a car. But if you combine these 2 parts in one car or application, you can choose which views you are going to be implementing in 3 layers, which views you are going to be implementing in 1 layer. And that way, I would claim that you would save a lot of work if you can implement most of the application on the server side and only put this 5 times effort in the views that really need to be offline. Offline was just an example over there. You could also, any of those reasons for being on the client side would have the same trick. So basically, if you need a low latency for 1 view, it doesn't make sense to build whole application on the client side if you don't need that low latency for these views. Okay, how much time do we have? Do you want to have like quick intro to Vaadin as well, or?
Sure, I'll quick.
It's up to you guys.
Well, why don't you ask them?
Silence. So just kind of quick pointers about Vaadin. Today we are in 7.1 version, so this is not a new framework. We actually started in year 2000 already building this framework and released the first version in 2002, so it has a bit of history behind it. While GWT, the optimization target for GWT is clearly scalability and being as efficient as possible. For us, the optimization target is combining rich user experience with developer productivity. I'll show you a bit of demo. So, how many of you have seen Vaadin sampler? 4 guys. So this is, maybe I just put it like full screen. Oops. So this is a way of kind of seeing what kind of features are in Vaadin. You can basically go through different UI components. Let's take any example from here, like date picker. You can try it out, see how it works, and then you can take a look of how it's implemented, or should be. Why not?
So this is one of 3 components.
These are all free components. The whole framework is free and Apache licensed. So you could take a look of the source code, how this example was implemented, so you are kind of learning out of the examples. You can try to configure the example somehow, let's say some other local over there, and you can enable and disable features. And then you can go from component to see how these work. And there are quite a few components over there, so I don't go through these, but there is also like other type of samples, like let's say the RPC mechanism that we took a look of. You can kind of see how it works. Here is a client-side widget, to-do list widget, and the server-side API for it, and we can kind of try out how we are kind of modifying or sending over the AJAX calls over the wire. So you can actually use or inspect the DOM and see how things work under the hood as well. What else I could show you? Of course. I wanted to have a bit non-traditional UI for it because it's mostly used for demo and learning purposes, so you can have a bit of more playful UI for it. And then people have been criticized, hey, this is really hard to navigate. So and nobody is normally kind of finding this sitemap from here. So we have to probably figure out some other kind of UI, but I just wanted to have like PlayStation type of UI for this one. I could also show a bit more real-world looking sample application. So this is an application that is more like typical Vaadin application. You are putting tons of components on the screen, having like a lot of data. Things like lazy loading through million lines of data is fully automated. You just create a new data grid and connect that to a data source. You can also...
So is this also free?
Yeah. Everything you are seeing on the screen is free. You're clearly doubting me.
But I know like you have some components which are not.
Yeah, we have... let me show you... Yeah, so basically we have 3 commercial components at the moment. Charting libraries is commercial. Vaadin TouchKit is mobile UI library is commercial. And then we have regression testing tool based on Selenium for recording UI tests that is commercial. But we have been really strict in having most of it fully free and Apache licensed.
So this mobile framework, is it like pretty much compiles to native code for iOS and Android?
No. Everything is web based.
Pretty much all HTML5.
Yeah, so let me show you an example out of that. So let's take... Oh, this is a... Can I zoom it a bit? Nope. So, how do I press home button? So, for example, this UI is built with Vaadin TouchKit. So, what it gives you is like native looking UI components, helpers for building offline mode, detecting offline, and components that like are optimized for mobile devices, using hardware acceleration where possible and that kind of stuff. That said, all of the Vaadin applications that you build with the free framework, they work on mobile as well. So it's not necessary to have these components for building mobile applications. These are just a bit like extra on top of the cake.
Do you think about creating some native?
Not at the moment. So this is mostly optimized for business applications, and it seems that the HTML5 is powerful enough for those business applications.
Well, but you still kind of write native code for Android and iOS because of performance reasons.
You can wrap Vaadin applications with PhoneGap if you want to, let's say, scan a barcode and want to have this scanning done real time. So it is possible to do, but it of course adds complexity for your application. Let's see. Yeah, here is actually the same application run on iPad. So basically the same application runs as is on mobile device as well. Of course, if I would be running this on iPhone, the experience would be pretty bad because of the screen size. This is not designed for iPhone screen, but it's up to you how you are designing your application. And there are responsive features in Vaadin as well, so that you can stretch the layouts and fit these in the screen. So actually, maybe I could show this in practice. So let's see. This parking demo you saw already on mobile, but if I'm using that on a normal web browser, it basically has two columns over here. If I make it a bit narrower, then it's kind of switching to one column and so forth. But it's up to you to define how the layout should behave.
Do you have these examples available in Maven repository? Like how I can get more examples?
All of these are in Maven, are in yeah, they are basically in GitHub, and if you go to vaadin.com/tutorial, there are links for these as well. So one of the, I guess, the most powerful things in Vaadin is that there is a huge community around it, and these guys have been building a lot of UI components. So nowadays there are 400 add-ons for Vaadin. For example, how you are using these add-ons. Let's take a paper stack add-on. That is pretty useless layout. Basically puts your components on top of each other on a sticky notes. So you basically could put components over there and then kind of wipe the pages between those components. It gives you like code example how to use it, and after that you can just cut and paste the POM definition to your project, or just drag and drop the component to your project. Maybe I'll give a super quick code demo as well, because I guess that one of the great things is the development cycle. So just to kind of show that if I'm creating a new project, and let's see, our new project is over there, and start it on my web server. Like this, and let's see, what was the name of the project? Localhost. So now I have this application running over here, and first thing that we notice is that because this is real Java on the server side, what we can do is that we can put breakpoints in my code, and when I'm clicking something over here like this, it actually stops the breakpoint, and I can inspect what's happening over there. So you have like the full Java tooling available for you. Another thing is that you can modify the code. So let's see, now I'm kind of saying thank you for clicking. So let's see, thank you sfjog, save, and continue clicking over there, and it automatically updates. So the kind of cycle for developing is pretty fast. You can kind of go back and forth between the code and web browser easily. And as you already saw, the components are pretty powerful, so let's create a super quick demo file. Because we are on the server side, we can do crazy stuff like access file system. Let's see. I have some files on my temp directory. So now I'm accessing these files from my directory, and then I can just put these on the screen. Let's say layout, add component, new table component, and table component could say like docs, and I just show the docs from my file system. So 2 lines of code. Actually, this is an example of I have never tried out. We'll see if it works. So now I'm listing documents directly out of my file system. So these components are pretty powerful, and you can kind of start building your application like piece by piece and seeing changes on the screen immediately. But I guess we are running out of time, so let's not code anything extra for now. I just mentioned a couple of things that we have lately added to Vaadin. So one of the things is that there is SAS compiler. I don't know who knows SAS. Couple of guys. So this is a really awesome way of structuring your CSS. And then we did the craziest thing. We wanted to have like notation on top of CSS. Took the, I would say, top 1 project for that over there in the world called SAS. And instead of using their compiler, we re-implemented the compiler in Java because we wanted to have that in the product package. So there is a SAS compiler in there. You can build add-ons with JavaScript as well. So obviously you can do that in Java with Google Web Toolkit, but you can also use JavaScript language nowadays in Vaadin. There is a server push mechanism. And now we are working on a really nice grid component that is going to be out in Q1 that I would claim is the like best data grid in the world, but we'll see in 1 quarter.
So when did you say it was expected?
Yeah, Q1. Yeah, there is a like early preview version downloadable today, but it's not usable yet. So how to get started? Basically, there is tutorials on the web. We have plugins for all major IDEs. So for Eclipse, you go to Marketplace. For IDEA, it's built in. For NetBeans, it's on the NetBeans plugin central or plugin portal. There is Maven archetypes. But I would say that the best way to get started is Book of Vaadin. This is a 700-page book, basically documenting everything of Vaadin, and you can download it for free from vaadin.com. Or if you are seeing our crew on some conference, we probably are giving out hard copies of the book as well. So, but that's tend to be most of the time outdated because after you print it, it's going to be outdated in 2 weeks anyway. So. And the whole framework is Apache licensed and free for any kind of applications. And there are quite a bit of community. We don't know exact number how many developers we have in the community. We are seeing around 150,000 unique visitors each month on the developer portal. So that's one indication of the community size. Yeah, that's it. Any questions? Yeah.
I have a packaging question. So I've seen that you're using the Tomcat server. Is it possible to have something like a standalone artifact, like a FatJar type of deployment?
I guess so. We can use. You can use any Java compatible server or portal, and I have seen people do pretty crazy stuff like packaging Vaadin to be run on Android device natively, basically running a JD-based server on the Android directly. So that's possible. I have also seen in the past some products that have been packaging Vaadin as a desktop application, but I don't know whether that's a good approach. So most of the world is going to web anyway. So, but basically any kind of Java compatible server will do that can serve servlets. Anything else? Okay, thank you guys.